Hello, welcome to assembly tutorials. Today I will be teaching you how to create an assembly file that outputs hello world. So first of all, you're going to have to create a folder. You don't have to, but you can, just to organize. So I've created a YouTube assembly folder. So what we're going to do is we're going to create a file named helloworld.asm. The ASM part isn't necessary, but you can use it. Okay, so first of all, before we get into anything, we have to since this is the first video, we're gonna have to install some packages. So you're gonna need NASM. So if you do not have that already, type in this code. Pause the video and install this. I already have it installed, so I do not need to do that. So sudo apt-get install NASM, and then the second one is sudo apt-get install NANO. NANO is a text editor for coding, and NASM is the compiler for your assembly applications. So once those are both installed, we're gonna create a file. So we've already created helloworld.asm. We're not in that folder yet though, so we'll open it by right-clicking the folder you created and opening open terminal. So what we're gonna do is nano helloworld.asm to get into that folder file. So first of all, this is assembly, and if you're new, which you probably are because this is the first video, and if this helps you, make sure to leave a like button and subscribe for future videos. I'll be doing assembly and C# tutorials for now, possibly C in the future, so let me know. So we're gonna have to create a section.data. This is where all of our information is stored. So like strings and stuff like that. If you came from C# or higher language, higher level languages, then they're known as strings. But in assembly, they're just bytes. So we have to create a section.data, and this is where, for our series, our information will be stored, such as like strings and stuff like that. But they're not really called strings in assembly, but I'll just speak English. So what you want to do is create this section, and inside we're going to create a message. This can be named anything. It's basically just a variable. So message, so db means define bytes. So we're going to get the bytes. We're going to define these bytes that we print. So this doesn't have to be a string or the quotes, but you can also just type set this as like an integer and have a 0, and you can do mathematical operations using it. But for this video, we're just going to be doing hello world. So we're going to create a message. We're going to create message. It can be named anything like hello world or anything. So we'll just name it message1 for short. And so message1 define bytes. We're going to print in our thing. So hello world. And if you want a new line afterwards, just do comma 10 and 13. This is 2 extra bytes, and it'll give you a new line character. So it will help when we output it, so it's not necessary, but you can use it. So we're also going to have to get the length. We can do it by hand. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We could do that, but we're going to make it automatically get the length. So what we're going to do is we're going to create another variable named message length, and we're going to equal it. So EQU means equals. You can, so equals. What this does right here $ minus message is basically going from the start of the message to the very end of the message and counting the bytes. So that would be 12 bytes it counts. So the thing is, you do not want to do this when you are getting user input. Basically because there's always an error, and for some reason it doesn't work very well like that. But we're not getting user input, we're just printing out to the screen, so that's alright. We're now going to create a section.text. This is where all of your code goes into. So we'll create global_start, and what this does is it creates a function start that this will be the entry point for the program. This is basically where it starts. So in Linux it uses _start, in Windows it may use just start, but so we're gonna do _start and then colon, which will basically tell it that this is the function and execute all the code inside of it. So basically we don't have to do this, but this will just save us. This will just teach you some more. So we will use the call event. And what are we going to call? We're going to call print message. You can name this anything because we're just going to be creating another function over here, which will be called that. So it could be print my message, or it could be anything as long as you have it the same down here. And what call does is it'll call this, and then as soon as it returns, then I'll start executing the rest of the code over here. There's only 3 blank lines, so nothing's really there to be executed. But so print message, instead of here, we're going to have to move 1 to racks. Because we're using Intel, it looks like this. You can use AT&T, which would be move 1 racks, or move 1 racks, but you may need a different compiler, or you need to configure your compiler. We're using NASM, so it's the main configuration is Intel, but it might vary on your CPU possibly. I've never used AT&T, so I don't know what I'm talking about. So what we're going to do is move basically copies a value to something. So we're going to move 1 to racks. 1 to racks. And what that does is basically it's going to tell racks that we want to write to the screen. So we're going to use the syswrite, which is syswrite. Okay, so move racks 1, calling system write basically. Then we're going to move RDI to 1. This means studio output, std out. This is going to tell it that it's going to be outputting something to the screen. Okay, so now we're going, okay, by the way, if you didn't know, these are called registers, and there's a thing in your CPU and they just help with code. I did not go to computer science, so I'm not 100% exact on what the registers really do inside of the CPU, but I do know that the CPU is the processing unit where it processes the ones and zeros that go through it. By the way, all of this code turns into ones and zeros for the CPU. So it's for the instructions. So we're going to do move RSI message 1. So message 1 is the thing we declared up here. So it's going to say, okay, so we want to use system write, and then we're going to print to the screen. We're going to print something to the screen. Well, what are we going to print to the screen? It's going to ask RSI that question. RSI has this data, so we'll tell it we're going to print this data. So now we're going to move we're going to move the message length, which we declared above too, to RDX. So it needs the length, the string, what it's doing to work. So we're going to do syscall, which is going to take all this code and basically run it. So it's gonna understand that it's using system right, std output, message 1. It's gonna be printing message 1, and it's going to be using message length. That's the length. So it's gonna call that. It's gonna run that code, and now we're gonna have to return back. So after we return, these 3 lines are executed, then we get a syscore fault error. What that means is that it did not exit properly, or there was an error. So we're going to move rack 60, and what moving 60 to racks does is basically tells it that it's using sys error. It's going to become a sys error. Now we're going to move RDI 0, because we do this. Okay, you can change this to any number depending on how many errors you want, but like to exit with error. But we do not want this to exit with any errors, so set it as 0. We're gonna run this code. We're gonna call it. Set an interrupt basically, and this program should work. So now we're gonna do Control S. Now we're gonna do Control X. Control S saves it. Control X exits out. So what we're going to do is we're going to compile this code. So we're going to use NASM. Just type this, so NASM elf, f-elf, or dash f, elf 64 for 64-bit. Then we're going to have to get the name of the file, so hello world.asm. We're going to create an output file of hello world.output. So it says error, simple message undefined. So there's obviously an error, so let's go back into our code. Okay, so it's trying to get the length of message, but message does not exist, but message 1 does. So we'll fix that, and that's fixed. Now we'll save that, Control X to exit out, and rerun that code. So now we compiled it. So we're going to use LD as the linker to create this as executable from our file. So LD hello world.output, and we're going to output that to hello world. So if we list everything inside of here, we see hello world at the very end is green, basically because that is an executable file now. So if we run that, we get hello world, and there's a line break. If there wasn't a line break, then Shango at Shango-Falco would be in front of hello world. So that is basically how to program x64 assembly and hello world. So let me know in the description if you want any more tutorials. I'll make sure to help you out if you have any errors. And that's the end. So see ya.